In this lecture, we will learn about the specifications command that can be accessed in general and specifications here. And this is like the most important commands which help us in bridging the gap between the analytical models and physical models. Analytical model means that whatever we are creating in the software itself, and physical model is the thing that will be actually constructed on the site, or that will be actually used by the people that may be living there or using that structure. So it's a structural engineer's job to bridge the gap between the analytical models and physical models. That is, to make our analytical model same as much as possible as the physical models. So there are various scenarios in which the software demands that we input the specifications. The specifications option will be much more clear if we do it with the help of practical examples. So starting this window here, we can see that there are various options, that is edit, delete, node, beam and plates. So three types of specifications can be assigned. That is, in node there are these two specifications. In beam there are various number of specifications. That is release, offset, property detection factors, cable, truss, imperfection, fireproofing, inactive, tension and compression. And we can also assign the plate specifications. That is, we can either release some end of a plate, or either we can ignore in-plane rotation, ignore stiffness, plane stress or rigid in-plane rotation. So all these specifications we will discuss in various lectures that will follow this lecture. So but before that, we need a practical structure to input all these specifications to make the things more clear. So to start, we need to open the editor. You can enter units as meter, kilonewton. We can enter joint coordinates 1, 0, 0 and 0. And we can press nodes cursor here and press shift plus K option on your keyboard. So this is an arrangement that is usually done by me, but maybe some people are comfortable with this geometry and snap, grid and node and beam option. So here they select some node and then start modeling. So it's all up to a structural engineer's perspective that how he starts the structure. I am comfortable with this, so in all the lectures I will do this only. So we press this node cursor here and press Ctrl C and Ctrl V on your keyboard to just copy paste, and press select 6 meter here. So select both these cursor again and press Ctrl C or Ctrl V, or either you can, what we can do is that edit copy and edit paste node. So here you can also see that the software is suggesting either we can press Ctrl C and Ctrl V again. So it is asking by what distance we need to repeat this arrangement along y-axis, that is, let us say 5 meter. So after that we can add beam. So left click here and then again left click here, left click here and then again left click here, and now we have drawn 3 beams between 4 nodes. So we select the whole arrangement here and then just press translation and repeat along z-axis. Default step spacing, let us say as 5 meter, and number of step is 1 only. And if as we want to draw a structure along this z-axis, so we press global direction as z, and we can press link steps, or we cannot. Let us say we open link steps and open base. So here we can see that by pressing open base, it is not modeling a beam from this point to this point, or unless if we did not select this, so it is modeling a beam from this point to this point. So you can understand the importance of selecting the open base option in this translation repeat. And now we have drawn a simple framed arrangement here, and then what we need to do is that we can check the distance. This is 6 meter and this is 5 meter. So my suggestion shall be to insert a node here also. or we can insert a node here also. So as we want to model the structure along this axis, translation repeat Z, link steps open base. So our division of members shall be along this only. Why I am like creating this scenario, that you need to understand this is a steel structure. So what we need to do is that our major axis shall be along this. So if major axis is along this, so this shall be a main portal frame. This shall not be a main portal frame, this shall be a shear connected frame. And we don't want to put the loads on this shear frame. So to avoid that, what we need to do is that we can select this portal frame, and then we can select the beam here, and then left click, right click here, and then left click on insert node. You can select as add endpoints, that is add 2 points, 2 meter, 4 meter and 6 meter, and left click on OK. After that we need to go to geometry, add beam by perpendicular intersection. Draw this beam here, and then again this beam here. And after that what we can do is that now we have drawn this beam as primary beam, these beams as secondary beams, and after that what we can do is that we can model the tertiary beams also. So right click here, left click here, and then right click here, left click on insert node, add 4 points so that all the distances can be 1 meter, 2 meter, 3 meter and 4 meter. That is spacing between two joints shall be 1 meter only, and left click on OK. So now we have got some nodes here, and we need to go to geometry, add beam by perpendicular intersection. So now we have modeled the tertiary beams also. So this scenario maybe is somewhat confusing to the engineers who have just started using this software, as to what beam is primary and what beam is secondary and which beams are tertiary. I will repeat here. This is a primary beam, this is a secondary beam, and all these small beams of size 2 meters are tertiary beams. So now one more thing I'd like to add here, I'm deleting the structure, because whatever we are making here, that we can just translation repeat to make the things more clear. And so now coming back to this option, that is node option. So in node there are two options, that is master slave and flow diaphragm. See, master slave is somewhat a controversial command that I will not suggest for the novice structural engineers to follow. For that is those structural engineers who are not much familiar with this diaphragm option and master slave option, I will not suggest you to do that. My personal suggestion is to use the flow diaphragm option only, because master slave option is just to make a diaphragm also. So what we can do here is that we can model the diaphragm for this whole arrangement. Let us say this whole arrangement is this whole structure sheet arrangement. On the top of it a deck slab shall be constructed. So what we can do is that we can model a composite deck slab here, but to stimulate the effect of this composite deck system we need to put a diaphragm, or in whatever RCC structure that we are modeling in STAAD Pro software, and we are doing the dynamic analysis. So to do that, this flow diaphragm option is a compulsory option that we need to follow. Most of the novice structural engineers or like graduate structural engineers don't have much idea about this option, but this is a must to do option when you are going for perfection of the results. So flow level, what we can enter here is that our floor height is approximately 5 meter. So what we can do here is that we need to go to floor diaphragm option, and height we can select it as 5 meter. Or some structural engineers might be comfortable with using this option, that is 4.9 and 5.1. That is whatever nodes are between this 4.9 and 5.1 meter, the software will automatically assign a diaphragm here. Master node information, we need to calculate that. Master node is a node that is the center of the whole floor here. And if we are selecting this option, STAAD will automatically generate a pseudo node. I'm repeating, a pseudo node, imaginary node. That node you cannot select, or you cannot copy, or you cannot paste. That shall be a pseudo node, and that shall be calculated and stimulated at the back end of the software itself at the time we analyze that. I'm repeating this thing. This is a very important thing. When we are selecting master node information as calculate, the STAAD Pro will automatically calculate or stimulate an imaginary node that will be stimulated at the back end of the software itself, and it will show that node at the time of the analysis. And these things will become much clear when we will do the analysis. And after that, we have two options. That is, either we can select nodes, or either we can select the floor range. Floor range is an option that we will study when we are studying the load basics. But now at this stage, to keep the thing simple, I will suggest you to select the nodes and then left click on add here. Now we need to go to view from +Z, select the nodes cursor here and select all these nodes. So now you can see that assign to selected nodes and assign option is now selectable, and then we left click on assign, and then we again left click on yes. So unlike eTabs which generate like various lines, STAAD Pro will not do that, but it will generate that when we will do the analysis only. So now we have studied how to assign a floor diaphragm. So now we have assigned floor diaphragm to this much structural arrangement only, and after that we need to study the beam specifications also. In beam specifications, in this lecture we will study some specification, and some specification we will study in the next lecture. So now we can see that we have a command or option known as the release option. This is the most important option, or this is the most used option in the STAAD Pro software. If you are comfortable with eTab software, or if you have studied the basic structural steel design in your college, then you must have known that there are two types of connections: shear connection and moment connections. When we are using the moment connection, we do not need to assign release. We need to assign release when we are stimulating a shear connection only. So what exactly is a shear connection? You can Google that, or you can refer to the basic structural steel design book. But in this lecture, we will try to stimulate the shear connections in the structural steel arrangement. So first of all, I want to make some things clear to you. This is a moment connected portal. I am repeating. I will select that in the plan view option only. This is a main portal that will transfer this whole structural steel floor load to the foundation. This is a moment connection. The connection that will be between this column and this beam shall be a moment connection. Connection that shall be between this beam and this column shall also be a moment connection. Same is the case with this and this and this and this. So, but one thing that I'd like to add here is that I want to make it a shear connection. That is, this member of 5 meter length, I want to make it a shear connected beam. So how we can do that? We can go to beam, location, beam and release. Location we can select it as start, and we can select it as MY and MZ. That is what we are doing here is that we are releasing the member capacity for taking moment along y-axis and moment along the z-axis, and we can left click on add. Similarly, we select the beam option again here and end, and my and mz, and then again left click on add. This thing might be confusing to you, so to explain that I will just go to this view. So what exactly I am trying to convey here is that this in real shall be a single member, unlike in STAAD Pro when we have broken this into 1, 2, 3, 4 and 5 different beams, but in reality it shall be a single beam of 5 meter length. And when we will press Shift plus E option on a keyboard, you will see that this green color and blue color will be selected. Green is the starting point and blue is the ending point. That is, a member start at this point and ends at this point. And similar is the case here. So what we need to do is that we need to assign releases at the start. That is, we want to assign release at this particular junction. So we select this beam here, left click on start and assign to selected beams. You can press Shift plus E option on your keyboard again, and here you can see that a small circle will be visible here. So here you can see that there is this small blue circle here. So what exactly this option is explaining to us is that we have released this beam on the starting junction. Similarly, we need to release this beam on the ending point also. So we select this beam and then left click on end and then again go to assign. So now we have shear connected this beam from this column to this column. Similarly, we will do the releasing option here also. That is, it's not necessary that you press Shift plus E on your keyboard again and again. You can just hover your mouse over this beam and then you will see that STAAD Pro will automatically saying that this is the starting point. So you can left click on start again and then again you can press end option here. So now we have released both of these beams from this point to this point and this point to this point. But the releases are not finished yet. You need to you need to assign releases here also. That is from this point to this point and this point to this point. So we go to plan view and press Shift plus E option on a keyboard and then select these beams here and then select start and then end option here. So now we have released these two beams also. Why we have released these two beams? Because this is a beam to beam connection, and beam to beam connection can never be a moment connection. It has to be a shear connection. And while detailing the connections also in the steel structure, we make sure that we don't connect the flange of the structural steel section. We only connect the web of the structural steel section so as to only transfer the forces, not moments. So now we have assigned this secondary releases to secondary beams also. Similarly, we need to assign releases to the tertiary beams also. That is all these small beams. So we go to assign, start and end option also. So now we have correctly assigned releases to all the structural steel members. See, if you are watching this thing for the first time, or if you have heard the word release for the first time, this option shall be very much confusing to you. But I will suggest you to go and study on this option to much detailed extent, as this is a very important option that helps us in transferring or like generating the forces correctly. So in this lecture we have learned how to assign the diaphragms and how to assign releases to the beams. So in the previous lecture we have assigned diaphragms as well as releases to these members. Now to make the things more clear, we will go to the general and property tab and then we will select some structural steel members. So to do that we need to go to this property and left click on section database. So in section database we can see that there are various structural steel section libraries that are already inbuilt in the software. So we can select, for example, let us say British sections, and we can go to UB. So we can select UB 457 into 152 into 52. 457 is the height of the member, 152 is the width of the flange, and 52 is the kg per meter unit weight. So it means that the weight of the section is 52 kg per meter. And left click on add, and similarly we can select other sections also. So let us say if we want to select the channel also. So channel, we can consider it as channel of, let us say, 125 into 65 into 15. 125 is the height of the member, 65 is the width of the flange, and 15 kg per meter is the unit weight. And similarly we can select a small structural UB size also. The UB means uniform beam. So we can select UB 305 into 165 into 40 also. So we go to this member and we can select it as UB 305 into 165 into 40. After that we can select this member also as 305 into 165 into 40. Make sure that you don't select column while making a rectangle like this. And we can select these small tertiary members as channel of 125 into 65 into 15. And this member can be selected as this main portal frame member, or main moment connection member. And after that we can select the column size also as same this member also. So now we have assigned properties to all the structural steel members. And after that I will like to make some things more clear to you. Basically what happens is that when we select this member here and this member here and go to 3D view, so here you can see that this member is coming inside this member. So although this member shall get terminated here only at the face of the flange, but it is coming to the center, which is not correct. So it may result in underestimation of the bending moments, because the whole force will get transferred here, whereas there shall be some eccentricity to the actual force or the moments that are happening here, because we assign connection to the face of the member. So here you can see that we need to finish this member on the face of this column only. So although this is a practice that is really done by the structural engineers, but I will suggest you to do that. So how to do that is the main thing. So we go to general and specification, we left click on beam. Here is this command called offset. So offset is the command that will help us in correcting that thing that we have discussed earlier. So we go to location and start. Here we can select as offset of global X. This is the global X axis. So we want to offset this joint of this member by 0.225, because we have selected UB 457. As I told you earlier also that 457 is the height of the structural steel member. So we need to select it as 0.225 and left click on add. Similarly we need to offset this member also, but before doing that I would like to assign this specification here. Left click here and then left click on assign. So if we want to check the 3D view here, we need to select start here. So I'm repeating this. I had done the mistake earlier that we need to select the location as start, not as the end. So when we select when we will do this and then left click this member here and this member here, then here we can see that now the connection is correct. That is, we are terminating the structural steel member here at the column, face only. So similarly, we need to select beam and offset as location end and x as 0.225. So we need to do the same thing here also. We need to select offset x as minus 0.225 because we need to go along this minus x. So here you can see that the STAAD has drawn some hidden lines here. So it means that now the member is offset by 0.225 mm distance. So similarly, we select Shift and E option on your keyboard to switch on the local incidences. And similarly, we select this starting point here and ending point here. So now we have studied what exactly is the importance of this offset command. So if we want to fine tune our bending moment and shear force results, then we need to do this offset commands specifications. And similarly, one more thing that I like to add here, you can press Shift plus E on a keyboard again to switch off. If we want to model a floor on this structural steel member, for example, if we want to model a 150 mm slab here, so we can left click on add 4 knotted plate and select all these 4 members here. So now we have modeled a plate here. To select the plate, we need to select plates cursor here. So you have selected this plate here, and we need to go to general and property, and we need to select the thickness here. And on the top it is plate element thickness, you can select it as 0.15. And we can select the material as concrete, left click on add and close. So selecting this plate cursor here again, and we can left click on assign to selected plates and gaze. And when we will go to the 3D view, here you can see that again something is wrong. Again something is not as desirable as what we want, because this 150 mm RCC slab should be over the structural steel member, not on the center line of this whole structural steel member. So to correct this, what we can do is that we need to select all these members here, select the beams cursor here and select all these members here. We need to go to general and specification, and we need to go to beam, offset, and y as minus 0.225, because overall the maximum height of this member was minus 0.457, and the height of the plate that is being modeled is on the center line. So that is why 457 divided by 2 approximately minus 0.225. So and y is plus y is on the upper side, and we need to down these elements. So we need to left click on add, and we need to left click on assign to selected beams and yes. So similarly, we need to go to beam and offset and end and y minus 0.225 and left click on add. So although what we have done here is a rough method, and one more thing that I'd like to add here, that now this offset command that we have assigned earlier to these members are now superseded. So what we need to do is that we also need to offset these members along the minus y direction as well as along plus x and minus x direction. So we can change it to minus 0.225 and this member also. So now if we see this whole structure in the 3D view, so now you can see that this is now a correct approach. Although we have done one mistake here, that we don't need to offset the channels also by same dimension, because channels are of 200 mm size only, and this beam also is of somewhat less size. So what we can do to like rationalize this whole 3D view is that we can offset this channel by 100 mm only, that is MC 125, and this whole structural steel arrangement is now perfect. That is, this member is now resting on this as we desire, and the structural steel structural RCC slab is on the top. And if we will see the channels here, we can see that now the channels are hanging in the middle. So here you can see that channel is like not below the deck slab. So what we can do is that we can go to specification again, and we can assign a new specification, that is y minus 0.1. and similarly for the end point also. And to reduce our working time, we can go to CH125 into 65 into 15 and select these whole members here, and go to specification, select this, and we can go to left click on assign to edit list, press Ctrl plus V on a keyboard, and left click on assign. Similarly for ending point also. So now if we check the 3D view, here we can see that still it is not correct, as the structural steel member is going inside the deck slab. So what we can do is that we need to change it to minus 0.2. Basically this problem is occurring because we are offsetting the whole member, both of the members. So we need to take the differential of this, but to make like the things precisely or correct, then what we can do is that we can change this to minus 0.15 to check that whether the things are now correct or not. Now we can see that the whole arrangement is now somewhat correct. That is, now the member is now resting here, because as I told you earlier also, because we are offsetting both of the members, so we need to take the differential, not the like height divided by 2 for the small tertiary members. So sometimes you do need to do permutation and combination to check that what is suitable for you and what is not. There's one more thing that I'd like to add here, because in structural steel members we also have bracings here. So how we can add the brace is that we can just left click on add beam, and left click here, and then left click here again. So similarly we need to model a bracing from this point to this point. So how we can make sure that this member will only take compression, or it can only take tension, or it can only behave in a particular manner. So how we do that is that we can go to left click on beam, and we can select compression, tension, or we can assign releases, and we can assign truss also. So different structural engineers have different perspective of how to deal with the bracings. I will not suggest you to assign truss members to the bracing, because in reality some bending moment may come in the bracing structural steel members. So how we can avoid that is that we need to assign releases to these bracings. So to assign releases to the bracing, what we can do is that we can select both of these structural steel members, and we can left click on start M by MZ and end M by MZ. So this also was although was just a basic introduction to how we like assign properties to the structural steel bracing. But what we need to do is that what I am trying to convey here is that the bracing connection also need to be like justified. That is, we also need to make sure that this bracing is being converging on this column on this working point only, because otherwise, for example, if we are seeing here, the bracing is not coming on the center line of this beam, it is coming on the top of this member. So it may result in the underestimation of the axial force and bending moments. So as I told you earlier also, that we need to bridge the gap between this physical models and analytical models. So what we need to do is that we need to make sure that in fabrication drawings or like on the site, this structural steel member shall be center line of the structural steel member shall be on the center line of this column only. So if we are talking about our structure, so in the bottom we can see that the center line of these both members are coinciding on this particular joint. So we can say that this detail is being correctly followed here. But I need to ask you this question, that how we can like model this type of bracing connection. Let us say the fabricator is saying that he cannot due to like length of the bracing, he cannot do this type of connection on the bracing column intersection, or he's saying that he wants to follow this type of connection. Then how we can analyze that type of structure? What we need to do is that we need to introduce a joint here. We need to introduce a small joint. So let us say the fabricator is saying that he need to offset the bracing column connection by minus 0. Let us say minus 0.4 meter. Sorry, plus 0.4 meter. So we can need to select Y plus 0.4. You need to press Shift plus K option on a keyboard. And let us say the fabricator is saying that he can draw bracings like this, or he can make bracing connection like this only. So with this we can make sure that this particular connection is being followed here, because let us say as I told you earlier also, that let us say we are offsetting the connection by 0.4 meter. So this is the thing that I am trying to convey here, that I am repeating this thing again and again, that we need to make our structure as much as possible to the physical structure or the actual structure that will be constructed on the site. So now we have studied this releases command and offset commands. So now we can understand that how we can define a particular flow, how we can assign releases, and how we can assign releases to the bracings also, and the most important thing, how we can assign offsets also to make our structure as much as possible to the actual steel structure. So in the previous lecture we have learned how we can assign offset and how we can assign releases. Now in this lecture I will teach you how to like fine tune this meshing, or how to proceed further with the plate system, or how to model the deck slab system. But before doing that, I will like you to please save as this model, because we will not use this plate in our final structure. I am just sharing this just for your the introduction to how this plate meshing and deck slab system works. So either we can go to file and save as the structure, or what we can do is that we can copy this whole structure here. Let us select 10 meter. We need to select the plates cursor here also, and same procedure for Control C and Control V, and then left click on 10 meter. So we can like do the experimentation on this structure only, and if things go bad we can go back to the structure. So left click on plates cursor here. Now there are various ways with which we can like model this deck slab system. either we can just delete this plate. Either we can go to geometry and composite deck system. So here we can see that this composite deck and create new deck option is coming. So we need to left click on create new deck. You need to left click here and then left click here and then again left click here and then again left click here. So we can name this deck as composite deck D1. So now we can see that this composite deck system is now modeled here with this diagonal blue lines, and it is showing various number of beams that are defining our deck slab system. So when we left click here you can see that this whole form will open. So if you are familiar to what are the parameters of the deck slab, all these systems will come here. So concrete thickness above fluids, so we can name it as, let us say, 0.075 or 75 mm. Unit weight of concrete, let us say 25. Concrete grade as 30 kilonewton per meter square. And now the rib properties, that is the deck slab that shall be installed here. So there is database also, that is either we can go with these predefined rib property system. So let us say we go with Verco PLB. So automatically it is defining the rib width and rib height. STAAD diameter is also very important system in this deck slab system. So either we can select the STAAD diameter as, let us say, 1/2 inches, and STAAD length as, let us say, 0.05 meter, and whether we can go with shored system or unshored system. So we can left click on update deck property to save. So now we have understood how to model a composite deck slab system, or this is this one approach. Or we can someone will want to say that he does not want this deck slab system on this structure shield members. He just want a RCC slab system. Or either we can assign the dead load of this RCC slab and analyze the structure. Or what we can do is that we need to go to geometry, plate. So here we can see that this plate cursor, plate number 54 is now available here. Or we can go to parametric models. So in the parametric models, save as this model again. So here we can see that this parametric model window will open. On the bottom there are various options, that is add, delete, merge mesh and remove mesh. So what we can do is that we can left click on add here, name as slab on steel, type as slab, and left click on OK. So here you can see that your cursor automatically changes. So what we need to do is that we can left click here and then select all these 4 joints. So this mesh parameters window will open. So we can either select it as basic meshing or standard meshing, element type as quadrilateral, and divide boundary segments to optimize the mesh quality. Target element size we can select it as, let us say, 0.5. So we left click on OK. And do you want to add openings? We don't need to add on any openings right now, so we left click on no. So here you can see that the software has generated this meshing automatically, and if you will watch closely here, this is 0.5 meter and this is also 0.5 meter. So if we want to merge this meshing to our original structural steel member arrangement, so we need to left click on merge mesh. So here we can see that the whole structure is now meshed. And why this whole thing is going up and down? Because we have added the specifications. So we need if we want to correct this structural steel arrangement, so we need to do the offset commands again. But this was just for an introduction to you that how we can go ahead with 2 approaches. That is, this is the deck slab system arrangement, and this is the plate system arrangement with meshing arrangement. So we have studied both of these arrangement, and I hope things are more clear to you. In general and specification, there is this plate system also. So in plate there is this command called plane stress command. So if we are doing the analysis like this in this arrangement, then we need to assign plane stress command to this plate. Otherwise the results may have some error cause of excessive stiffness along both the directions of this particular plate member. And if we study the various other specification of the plate members also, there are various like other features. Either we can assign release to a particular joint of this plate member. For example, here we have joint number 1, 2, 3 and 4. So for example, if we are assuming that this particular joint does not have any moment taking capacity or force taking capacity, then we can assign release to this particular joint. Or either we can ignore the in-plane rotation, or we can ignore the stiffness also. Plane stress already we have assigned, and rigid in-plane rotation. So although it is not recommended to model this plate, as we have this command called diaphragm. So if we are assigning diaphragm to this particular floor, then we don't need to assign plate element also. So this is just I'm explaining all these things for your clarity only. And if we go to beam, there we have already learned how to assign releases, and we have learned how to assign the offset commands also. And one more thing that I'd like to explain here, that in release option there is this option called partial moment release. So partial moment release is when we know that the only partial moment will travel through a particular joint connection. So in that case we need to assign partial moment release. So how we can assign partial moment release? Either we can assign partial moment release along the local axis, that is mpx, mpy and mpz, or we can assign partial moment release along all the three directions. I will always suggest you to go ahead with mpy and mpz partial moment release, because this is the parameter that is much more actual. So let us say this particular beam column connection between this beam and this beam, only this 30% moment will get transferred and 70% moment will not get transferred. So here we can see that 0 for full moment restraint, that is if we want a 100% efficient moment connection, we need to enter 0 here, and 1 for no moment restraint. And if we want a 100% shear connection, then we need to enter 1 only. But what if we want to this connection with only 30% moment taking capacity, then we need to select 0.3, because the more we are going towards 1, the more we are going towards shear connection. The more we are coming towards 0, the more we are coming towards the moment connections. So we can select mpy and mpz as 0.3 and select these beams here. So now we can be assured that only 30% moment will get transferred, and with this connection 100% moment will get transferred. And I am repeating here why we have not assigned this mpx, because any moment along x-axis is torsion. And basically why I am saying this, that we'll study in the next lecture about the local axis concept. In this lecture we will learn about the concept of local as well as the global axis. See, in STAAD software there are basically two types of axes that are present. One is the global axis, that can be seen from here, that is x, z and y. So this is basically the global axis. So when we will say global x, it means that it is along this direction, and when we will say global z, it means that this is along this direction, and vertical is the global y direction. But what do you mean by the local axis? See, basically each and every member is divided into local axis also. So to see further into this issue, we can select both of these members here and go to view and selected objects only. And now we can enter Shift plus O option on a keyboard. Press Shift and O. So here you can see that there are basically blue axis, green axis, as well as red axis. So this is basically, these are basically the local axis of each and every member. So if we will see the whole structure, here we can see that each and every member has its own local axis also, and which can be same or different from the global axis. So we go to our members under consideration. So here I want to say a point that red is basically the y-axis, blue is basically the x-axis, and green is basically the z-axis. So you need to remember this pattern, that is red, blue, green, y, x, and z. So for this member, y is basically along this, and green is basically z, and blue is basically along the length of the member, that is x. So blue, that is x, this is the torsional axis. Green, that is z, this is the major axis. Red, that is y, this is the minor axis. But for this member, that is beam, here you can see that the red one is the y-axis, green one is the z-axis, and blue is the x-axis. So I'm repeating the point here that local as well as the global axis may be same and may be different. And one more thing I like to say here is that here you can see that both greens are pointing in the same direction. So for both of these members, what we can comment on is that the z-axis is local z-axis is along same direction. Similar is the case with the other structural elements also. In addition to that, for bracing also. So here we can see that for bracing also there are particular local axis. So it is like the by default of the software that it will divide each and every member into the local axis. But what is the significance of this local axis? So if we will go to the general load and definition here, when we will start like adding loads, so it will ask us that whether we want to add the loading along the local axis or we want to add the loading along the global axis. So this is a very important concept that you need to remember and you need to understand, that is what are the local axis, what are the global axis, like which color represent which axis. So you need to learn this, or you need to remember this pattern, that is red, blue, green, y, x, and z. In this lecture we will study much further about the beam specifications, that is those specifications which we have not studied in the previous lecture. But before that, I will like you to press Shift plus O on your keyboard to switch off these local axis, and I would like to delete these structures that we have just made for our education purpose. So coming back to our original structure, I would also like to delete this plate structure. So now in this lecture we will study much more about the beam specifications, that is truss, compression, and tension. But before that, I will like to add some beams here, that is we can add this beam here and this beam here, and we can also add the bracings also. So this is the plan bracing that we have made here. And now, as in our original structure we are not modeling the plate, then we can also delete these vertical offsets that we had made. So coming back to our original structure, so now in this we will understand what exactly is the compression. So by enabling a member to be compression only, so first of all we need to select the compression here and left click on add, and if we are selecting this bracing as a member compression only, so only and only axial force will be traveling in these members, and only and only compression force will travel here. And when we will select tension here, so only and only tension force will be present here. And there is this one more thing, that is truss. So by selecting truss, both compression as well as tension can develop in a particular member. So for example, if we make a member like this at the center and we select it as member truss, so only and only axial force will travel in this member. Not a single unit of moment will be developed in both of these members. So this member truss has to be used judicially while you are modeling a structure, as any incorrect or excessive truss specification can lead to instability in the structure also. So now we have understood how we can assign compression, tension and truss specifications. After that there is this one more thing called fireproofing. So if our structural steel members have fireproofing also, then we can assign this specification also. Here there are two parameters, that one is the thickness and the second thing is density. And this fireproofing type, one is the block fireproofing, that is whole of the structural steel member is embedded in a fireproofing material. Second is a contour fireproofing, that is the structural steel members are covered in a fireproofing material in their particular contour only. So now this thing is clear to us, that how what is the basic difference between contour and block fireproofing. If we will Google about this, then this is the practical scenario on a site. Here you can see that this is the contour fireproofing, that is the fireproofing is done along the contour of this structural steel member. Same is the case with the beams here also, that is fireproofing is done along the contour of the structural steel member. So if you Google the block steel fireproofing, then you can get this result here. But I hope you are understanding the scenario here, that how the things are done on the site. So now we have studied about the fireproofing specification also. There is this specification called imperfection specification. Imperfection is like when we are assigning a particular pre-camber to the structural steel member. Pre-camber is done when the span of the beam is very high. Let us say it is in the range of 12 meter or in the range of 15 meters. Then the structural steel member shall sag in its own self-weight only. So to avoid that, what we need to do is that we can assign a particular pre-camber to the structural steel member, and to assign or to consider the effect of this pre-camber on a structural steel member, then we can assign pre-camber here. Let us say the value is of the pre-camber is approximately 25 mm. So we can assign y, and we need to select the local direction. So we need to select the local direction according to the axis that is being visible here. And drift is like when a particular structure has already a pre-installed drift in the structural steel columns. So drift is like the in simple what we can say is the deflection that has already occurred in our structural steel member. So if we are considering that, then we need to assign the drift specification. And one more thing that I'd like to add here, when we are considering the camber, there is this respect called 1.6. Actually STAAD calculates the epsilon for the calculation of this pre-camber, and when that epsilon according to this respect value is not considerable, then STAAD does not consider any effect of this pre-camber. But when both respect and this pre-camber value, by considering both of these values, the epsilon is somewhat high, then the STAAD basically consider the effect of the pre-camber. And in Indian codes, you can take pre-camber up to for the specification up to the dead load plus 0.25 times the live load. And similar is the case with the American codes and Euro codes also, that these codes too define some pre values for the pre-camber specifications. So now we have studied compression, tension, inactive member. Inactive member means that no force will travel through a particular member. So when we are selecting inactive member here, let us say in this channel no force will be transferred, so we can assign this member as inactive. And when double clicking this member, here we can see that this member is assigned as inactive member. So now we have studied fireproofing, imperfection, all these specification we have studied. Truss we have also studied, and release we have also studied, offset we have also studied. Now property reduction factors and cable specification. Cable specification that we will discuss in the separate lecture series that we will study in the advanced non-linear cable analysis lectures. But property reduction factors is what our ACI code, our Euro code, and Indian code also, and Australian code also guides us about the cracking coefficient properties. But before assigning these properties, we can model a RCC beams also. So we select these joints here. Select the global direction as Y and default stress spacing as -5 meter and link strips. And we can make a floor here. We can model a secondary beam here also. So by selecting these members, we can left click on add midpoint and then left click on add beam here. So now we have modeled a RCC beams and column system here. So we need to go to general and property. Here we can go to left click on define. Here there are various features. So selecting rectangle here. So now again this is the Y and this is the Z. So selecting thickness of the beam as 0.3 and height of the beam as 0.5. Material as concrete, left click on add. So now we need to select these beams here. Yes. And similarly we can define the size of the columns also. Let us say 0.4 by 0.4 meter. So if we will select this beam and check in isometric, here we can see that this is 300 mm, this is the 500 mm dimension. And similar is the case with this. This is 400 by 400 mm column. Although we will need a bigger size column because our structural steel member is 457 size. So let us say we increase this its size to 650 mm to 650 mm. So now this is basically a composite structure that we have modeled, that is RCC structure on the bottom and steel structure on the top. We are modeling this structure just to make you familiar with all the specifications that are available in the STAAD software. So we go back to general and specifications and we go back to beam. So in the property reduction factors, as ACI code and Indian code both guides us that the reduction factor for torsional constant and moment of inertia, all of them shall be 0.35 for beams. So we have entered 0.35 for all the RIX, RIY and RIZ. And similar is the case with the columns. We need to assign 0.7. Left click on add here. So selecting the columns here. So and selecting the beams here. So now we have assigned property reduction factors to the beams here also, as well as columns also. This is also a thing that is not mostly done by the engineers, but that needs to be done.